All right, section 1.4, video part 6, completing the square. Remember I had told you at the end of the last video, completing the square solves all quadratic equations, every one of them. The problem is, if you look back at your notes, it's more involved. I mean, it's got 6 steps to it, technically 5, but 6 steps to it, and so it's a much more involved process than the factoring or the square root property. So if I'm going to solve a quadratic equation, if the factoring method or the square root property works on it, I'm certainly going to use that technique first before I use any other, the completing the square on it. So I gave you the steps, and so we're ready to look at an example. And then I will really hammer home that step 2. But you're going to have to really pay attention and listen carefully, because I don't want you to get confused on something on completing the square. So right at the end of class last time, you had written down a problem. I said, solve by completing the square. Solve by completing the square. And this was our problem right here. X squared minus 6x plus 59 equals 0. Okay, so I'm going to go through the steps. Step 1. Well, let me say this before I read step 1. I've already said this problem right here cannot be factored. There's no 2 numbers that multiply to give you 59 that add to give you 6. You can't use the square root property on this problem because it has a middle term. So if I'm going to solve this problem, the only method I have left on the table is completing the square. So let's go through completing the square. Step 1 in completing the square. Put it in their standard form. Remember, standard form means ax squared plus bx plus c equals 0. That means put it in the right order and set it equal to 0. It is. Now, step 2. Let me say this before I even read step 2. Step 2 will always be done for you. Then, Mr. Rayner, if step 2 is always going to be done, why do you even mention it? Here's the reason. Here's what step 2 says do. Let me just parenthetically state, or let me rephrase what step 2 says do. Step 2 says make sure that this number right here, and the coefficient of x squared, make sure that that is a 1. All right, let me make 2 comments. Number 1, anytime I ask you to do a problem by completing the square, that will always be a 1. This is the part I want you to hear, though. That doesn't have to be the case. If there was a 2 or a 3 or a 4 or a 5, you could still complete the square. But I would have to give you some other steps. And because we don't cover that in here, I'm not going to give you one like that. So if there was a 3, would completing the square still work? Yes, but not by the steps I gave you. So completing the square works every single one of them. But since we don't cover that, you're not going to need it. But I want you to understand that it doesn't have to be a 1, even though for you it always will be. All right. Second thing it said do is make sure that this number right here is even. It always will be. Now I'm going to say the same thing again here. Does this number have to always be even in completing the square? No, it does not. Can you still work the problem? Yes. Does how you work it change? Yes. The arithmetic changes. But because I will never give you that in here, you don't have to worry about it. But keep in mind that you can still use completing the square. I'd have to change the steps in the way I'm teaching it to you. You don't need it, so don't worry with it. So all of the completing the square that I give you, there will never be a number right here other than 1. And this number right here will always be even. They don't have to be to work the problem, but for you, it will always be that way. So just keep that in mind as we go through these problems. All right. So step 2 will always be a done deal for you. That's going to be a 1 and that's going to be even. Oh, let me say one other thing. I think there is one problem in your homework where it says solve by completing the square, and I think there's maybe a 3 or a 5 here. Or it may be that this is an odd number like 5 or 11 or 7. If the instruction says solve by completing the square, and this is not a 1, or this is not even, and this is not even, don't do completing the square. You say, well, then how do you want me to work it? Remember, we got 4 methods. So there's another method after this. So if there's one in the homework, completing the square, where this is not a 1, or this is not even, use method number 4. I will explain after this, okay? I think there is one like that in your homework. All right, so that step's done. Now go to step 3. Step 3. Move the constant to the other side. When you do, that becomes subtract 59 from both sides. Now, step 4 is where it happens. When you get to step 4, copy step 3 back down, but leave a space for your new number. So step 1, put it in standard form. Step 2, basically step 2, you can skip step 2. Step 3 says move the constant across. Now, here's step 4. Here's what step 4 says do. Take half of this number. What's half of 6? 3. And then square it. What's 3 squared? That's 9. And add that. But whatever you do to one side, you have to do to the other. Let me do that again. Take half of 6, which is 3, square it, which is 9, and add it to both sides. Sorry, that should be plus 9, not plus 50. Take half of 6, which is 3, square it, and add it to both sides. Now, one question commonly asked right here, students will say, Mr. Randall, when you take half of 6, do you take half of 6 or negative 6? It doesn't matter. Here's why. If you say half of negative 6 is negative 3, when you square negative 3, what's negative 3 times negative 3? Plus 9. So this is always going to be plus. All right, step 5. Factor the left side. Okay, let's factor this. X squared is x and x. Sign to the same, both negative. I need two numbers that multiply to give you 9, that add to give you 6. Is 3 and 3. Now, look at how that factored. This trinomial factored as something times itself. That means that's a perfect square. So when you factor this, it should always be the same thing twice. If it's not, you've messed up. Now, I don't want to leave it like that. I want to rewrite it this way. X minus 3 squared is x minus 3 times x minus 3. Now, what did it say do to the right side? It said simplify. Negative 59 plus 9 is negative 50. Now, that problem looks the way we need it to look, because now I can use the square root property. It has a square term and a constant term. So step 6, use the square root property to complete. That means take the square root of both sides. Now we've done this problem. We did it in the last video. When you do, this would be x minus 3 equals plus or minus 5i square root of 2. Where does that come from? I because of the negative, 50, 25, and 2, which is 5 square root of 2. Now, get the x by itself, add 3 to both sides, and when I do, I get 3 plus or minus 5i square root of 2. And that is the exact same answer that we got when we worked that problem before. So we made that problem up there look like this so that it is workable. How did we make it look like that? By the square root property. Okay. Let's do another one. X squared plus 10x minus 7 equals 0. Now let me say this before I work this one other problem on completing the square. First, I will specifically tell you on the test which one I want you to do by completing the square. Second, I will definitely ask you one by completing the square. Third, make sure that you know the steps. I can't tell you how many times students will walk in my office and they'll say, Mr. Rand, I just cannot complete the square. I cannot complete the square. I'll say, all right, let's sit down. Let's look at a problem. And when I start looking at a problem with them and they start writing it out, I'll look at them. I say, okay, what's the first step? Well, I don't know the steps, but I can't complete the square. You will never complete the square as long as you do not know the steps. So you have to memorize the process before you work the problem. You have to know the recipe before you can make the cake. So you got to know your process. All right, now, I'm going to go through this again. I want you to watch how easy this problem is if I know the steps. Here we go. Step 1, put it in standard form. That means put it in the right order, make sure it's equal 0. It is. Step 2 is always going to be done. Step 3, move this constant to the other side. And that becomes 0 plus 7, which is 7. So see, that's not hard to do. Now, step 4 is where you have to do a little work. When you get to step 4, copy step 3 back down and leave a space for your new number. Now, what's my new number? All right, let's read step 4. Take half of that coefficient. Take half of the coefficient of the middle number. In other words, take half of 10. What is half of 10? 5. Square it, 25, and add that to both sides. Half of 10, which is 5, square 25, and add it to both sides. Step 5, factor the left side. X squared, x and x. Signs are the same, both plus. Two numbers, if you multiply, you get 25, but if you add, you get 10. That's 5 and 5. And see, that's the same thing twice. That means that this trinomial is a perfect square. Now, I want to write it this way. Now, what does it say do to the right side? Simplify it. 7 plus 25 is 32. And then the last step, take the square root of both sides. X plus 5 equal, plus or minus 4 square root of 2. Where does that come from? Square root of 32 breaks up as 16 times 2, and square root of 16 is 4 square root of 2. And then the last step, subtract 5 from both sides to get negative 5 plus or minus 4 square root of 2. Or if you want to enter it separately, negative 5 plus 4 square root of 2, comma, negative 5 minus 4 square root of 2. Okay, so that's method 3. Now, method 4. Let me show you the purpose in method 4. You don't have to write this down. Just trust me when I say this. These two problems right here, if you tried to factor this by the Brew method, factoring won't work. This one won't factor. This is the easy case. 2 factors of 1 that add to give you 7. So neither one of these will factor. The first method's out. Next, you can't use the square root property on either one of these because they both have a middle term. Okay, next, let's try completing the square. Will completing the square work both of these? Absolutely. But remember, I told you the steps that I gave you to completing the square only works those that have a 1 in front. So the steps that I gave you completing the square wouldn't work this. Not only that, remember the middle number had to be even. So completing the square using the steps I gave you, I would not want to use on either one of these. So we have one other method, method number 4. Method 4. And it's called the quadratic formula. Okay, so write these instructions down. This is on method 4. Take this note down. Given any quadratic equation that is in standard form, and then write ax squared plus bx plus c equals 0. Given any quadratic equation that is in standard form, ax squared plus bx plus c equals 0. We can solve it by using the quadratic formula, which is and then here just right here is the quadratic formula. So pause that now and copy the formula. Okay, so I'm assuming you paused it and you've got the formula. Now, let me explain the quadratic formula to you. First, let me say this. The quadratic formula solves every quadratic equation. It solves those that factoring will solve. It solves those by the square root property. Well, then why don't we just use it every time? Because the factoring method is quicker when it's applicable. The square root property is quicker than the quadratic. I don't want to use the quadratic formula when one of those first